Okay, today we'll be looking at equations of constant acceleration, or as you may know them, the Suvat equations. Now, hopefully you're all aware what these stand for. So we've got S is displacement, U, initial velocity, V, final velocity, A, acceleration, and T is time. Now, initially we'll be dealing specifically with problems that deal with motion in one dimension only. Okay, so just horizontal motion will be our example today. Now, the first thing before we go any further, I want you all to grab a post-it note, and I want you to do the following if you haven't done it already. So, post-it note there. This will help you remember the equations. You're going to stick it on every bit of work you do, and by the time you come to the exam, you will remember them all. So, here we go. And we can now use that and stick it on every single bit of work we do. I'm just going to leave it there and pause it so you can write yours down. Well, you can pause it, not me. Done. Fantastic. Okay, get rid of that. Get rid of that. And here is our exam style question. A car is travelling along a straight road at 8 meters per second. As the car passes a tree, the lights turn red. The car continues at a constant speed for 10 seconds, then decelerates at a constant rate of 0.3 meters per second squared until coming to a rest at the lights. Calculate the distance from the tree to the traffic light. How long does this take the car? What was the average speed? Okay, so we're going to tackle part A first. We're going to stick our equations right there. Part A, we've got a road. We've got a nice tree at one end. There it is. We've got a set of lights at the other end. And they have just turned red. So our driver will need to stop. Now, somewhere in the middle of that, they decide to decelerate, apply their brakes, in order to stop in time for the lights. So we've got two sections to this problem, and we need to read through the question in order to get all the correct parts. We're going to write underneath each section S, U, V, A, and T in order to help us find everything we need. And then on the second part, S, U, V, A, and T. And it's now our job to pick out all the relevant information that we can find in the question. This is where your highlighter will come in useful. I'm just going to use one of my pens. First bit of information, we're told we're travelling on a straight road at 8 meters per second. The car continues at a constant speed for 10 seconds. We can fill those in straight away. So the initial velocity for the first section is 8 meters per second. Now, because that speed is constant, it doesn't change. So the final velocity is also 8 meters per second. And we know the time for the first section, 10 seconds. So 10 seconds can go there. As long as you have 3 of those 5 values, you can work out any of the others. So we've now got 3 for that first section. Second section, because it starts as the car applies the brakes, the initial velocity is 8 meters per second. We know that it is a constant deceleration, so constant rate of 0.3 meters per second squared. Now be careful, deceleration is always negative. We are taking that way as positive. So our acceleration is minus 0.3. If you put plus, the car is going to accelerate over the lights and get a ticket. Now, the last bit of information, we've only got 2 there, we need a third. Now, this is tricky. They've put coming to rest at the lights, which means the final velocity is in fact 0 meters per second. Not quite as obvious as the others. Now we have 3 values on each side. We can go ahead and calculate what we're after. So the first thing we've been asked to find is the distance. So we're after these 2 values, and then we're going to add them together. So we're calculating the distance from the tree to the traffic light. We need these two, we're going to add them up. So, first section, we have u, v and t, and we want s. We're going to look at our equations, and we're going to look for the one with u, v, t and s in it. So, u, v, t and s, that's this one here, our second equation. S equals a half u plus v times t. So we're going to put that in. S equals a half 8 plus 8 times by 10, which is just going to give me 8 times 10, which is 80 meters. So we can fill that in. 80 meters for our first distance for the first part before we start braking. Now after we've applied the brakes, we have a different set of values. We have u, v and a. So we need to use this last one here. V squared equals u squared plus 2as. So I'm going to put those in now, and this one I'm just going to write out to make sure we line up the correct values, because we're not working out the subject of the equation. So 0 squared equals 8 squared plus 2 times minus 0.3 s. And we now need to rearrange that. 0 equals 64 minus 0.6 s. And if I pull that over to the other side, we've got 0.6 s equals 64. So s will equal 64 divided by 0.6, which unfortunately is not going to give us a nice number, but we can always use our calculator. 64 divided by 0.6 is going to give us 106.6 recurring, or to one decimal place, 106.7 meters. For our answer to part A, you just need to add those together. Okay, second part. So part B asks us to find how long this takes the car in total. Now we already have the first 10 seconds done for us. We just need to work out this one now. So the time for the second section. So we've been given U, V and A. We've now worked out S to be 106.7 meters. However, I would not advise that we use this value. If you have 3 that you're given, use those. You're much safer using values you've given rather than those you've calculated. So for part B, we're going to use our top equation because it has V, U, A and T. V, U, A and T. So if we substitute those in, 0 equals 8 minus 0.3t. A quick rearrangement will give us 0.3t equals 8, so t equals 8 divided by 0.3. Again, use our calculator to work that out. 8 divided by 0.3 gives us 26.6 seconds, or 26.6 recurring, I should say, which will just be 26.7 seconds to one decimal place, giving us a total time of 36.7 seconds. And that only leaves us with one last part to do. What was the average speed? Now this is the formula you've been using since GCSE. So average speed is distance divided by time. So we now have our total distance of 106.7 and our total time of 36.7. So if we do that, 106.7 divided by 36.7 gives us an answer of 2.9073, etc. So we'll of course round that to one decimal place, giving us 2.9 meters per second as the average speed. So much slower than that initial. And that is how you tackle Suvat equation questions. Enjoy.